The James Webb Space Telescope has captured the most detailed image of Proxima Centauri B to date, offering stunning insights into one of the most promising potentially habitable exoplanets. This discovery invites us to embark on a cosmic journey to explore the mysteries of Proxima Centauri B, our closest known exoplanet, and question whether it could be a second Earth. Located just 4.2 light-years away, Proxima Centauri B resides within the habitable zone of its parent star, Proxima Centauri. But this is no ordinary rocky planet. Its proximity and unique characteristics make it an object of intense fascination. Could it harbor oceans? Might life exist on its surface? Adding to the intrigue, Proxima Centauri B isn't alone. Another planet, Proxima Centauri C, also orbits the same red dwarf star, and there may even be more undiscovered companions hidden in this system. What secrets does this neighboring star system still hold? Interestingly, Proxima Centauri B receives roughly the same amount of stellar energy as Earth does from the Sun. This raises a possibility of liquid water, and perhaps even life. As we look beyond our own solar system, we find a vast universe filled with exoplanets, worlds orbiting stars other than our Sun. With an estimated 200 billion stars in the galaxy, the possibilities are nearly limitless. Some planets even drift freely through space, untethered to any star, cosmic nomads of the universe. Yet, Proxima Centauri B stands out. Its orbit is so close to its star that a year on the planet lasts only 11.2 Earth days. One hemisphere of the planet is locked in eternal daylight, while the other remains in perpetual darkness, a world of extremes. Now, let's turn our gaze to the star it orbits, Proxima Centauri. It is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and B. Together, these stars form the closest stellar system to our own. Alpha Centauri A and B make up a binary system, G-type and K-type stars that appear as a single bright point in the Centaurus constellation, ranking as the third brightest stars in our night sky. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf or M-type star, located 4.2 light-years from Earth and about 4 times the distance between Earth and the Sun away from its sibling stars. True to its Latin name, Proxima, meaning the nearest, it holds the title of the closest known star to us. It was discovered in 1915 by Scottish astronomer Robert Innes. Despite this proximity, it remains invisible to the naked eye with an apparent magnitude of 11.13. Well below the visibility threshold of 6.5. Yet, don't be misled by its dim glow. Red dwarfs like Proxima Centauri are some of the most energy-efficient stars in the universe. Though they emit far less energy than stars like our Sun, their internal convection processes allow them to burn fuel slowly, enabling them to live for trillions of years. Proxima Centauri is expected to remain a main sequence star for another 4 trillion years. However, the question of whether such a star can support life remains contentious. Proxima Centauri is a flare star known for frequent and violent stellar flares. Its habitable zone is much closer than the Sun's, estimated to be between 0.023 and 0.054 Australian dollars, which places Proxima Centauri B in a potentially dangerous position. The planet is regularly bombarded with intense ultraviolet and X-ray radiation, far more extreme than what Earth receives from the Sun. This bombardment can strip away essential atmospheric components like hydrogen, nitrogen, and oxygen. Even if a planet is located in the so-called habitable zone, it doesn't guarantee it can support life. A major concern is that Proxima Centauri B may lack a stable atmosphere, which is critical for regulating temperature and retaining surface water. Without this protective layer, any potential life will be exposed to severe space weather and radiation, making survival nearly impossible. In the end, while Proxima Centauri B is tantalizingly close and filled with promise, it remains a world of questions. Could it be a second Earth, or just another barren rock in the vastness of space? Only time and further exploration will tell. Proxima Centauri B may seem Earth-like at first glance, but appearances can be deceiving. Despite its location in the habitable zone of its star, scientists remain cautious. Several harsh conditions could render it inhospitable to life. The search for the truth about this intriguing exoplanet continues, and one of the most promising tools in this mission is the James Webb Space Telescope, JWST. Launched in 2018 after years of anticipation, JWST is poised to help determine whether Proxima Centauri B has any of the essential ingredients for life. However, as is often the case in science, answers are rarely straightforward. Numerous technical adjustments were required to ensure the telescope could provide accurate and detailed imagery. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima Centauri B can absorb light from its star, it can also emit it as infrared light. This is exactly what JWST was built to detect: infrared radiation. By capturing this light, scientists can search for patterns that hint at the presence of water vapor or an atmosphere. But even the presence of an atmosphere isn't a definitive sign of life. Ed Turner, an astrophysicist at Princeton University, warns that just having an atmosphere doesn't mean the planet is habitable. Proxima Centauri B could turn out to be more like Venus, with a thick, toxic atmosphere and extreme surface temperatures that make life as we know it impossible. Still, the mission presses on. Although JWST holds immense promise, other challenges remain, particularly cost and the technological hurdles of observing exoplanets from such great distances. But the potential payoff is enormous: the chance to explore a nearby world that might harbor life. What makes Proxima Centauri B especially exciting is its proximity to Earth. It's the closest known exoplanet. That makes it an ideal candidate for future interstellar missions. It's almost like exploring our own cosmic backyard. Roughly the same size as Earth and located in its star's habitable zone, Proxima B is tantalizingly close to being a possible second Earth. Yet, reaching it is no small feat at Voyager 2's current speed. A journey to the Proxima Centauri system would take about 75,000 years. Enter solar sails, a revolutionary propulsion concept that could change the game. These ultra-thin, reflective sails harness radiation pressure from sunlight to propel spacecraft without the need for conventional fuel. In theory, this could drastically reduce travel time and allow us to send probes to our stellar neighbor. Solar sail missions could yield groundbreaking insights, not just into the planet's atmosphere, but also into the potential for advanced civilizations. If such life exists on Proxima B, they might even use vast orbital mirrors to redirect sunlight from the day side to the night side, an awe-inspiring possibility. JWST is sensitive enough to detect emissions that are as little as 5% the brightness of the planet's illuminated side. Given how dim Proxima Centauri is compared to our Sun, that's quite remarkable. But Proxima Centauri B is just one of countless exoplanets waiting to be explored. These distant worlds come in all shapes and sizes, from Earth-like rocky planets to massive gas giants. Some, known as super-Jupiters, dwarf even Jupiter and Saturn. Others, like hot Neptunes or mini-Neptunes, are closer, smaller variant of our solar system's gas giants, often cloaked in mystery due to their thick atmospheres and blistering temperatures. The universe is teeming with planets, and with each discovery, we inch closer to answering one of humanity's greatest questions. Are we alone? Jupiter's giant gas planets that orbit extremely close to their host stars exist in scorching environments where metals could melt. Imagine observing one up close, with its violent storms and searing temperatures. Alongside these gas giants are Neptunian exoplanets, which share characteristics with Uranus and Neptune. Among them are hot Neptunes and mini-Neptunes, smaller, closer-in cousins of gas giants. These planets often remain shrouded in mystery, largely due to the difficulty of analyzing their atmospheres from such great distances. Then there are Earth-like exoplanets, worlds that closely resemble our own. Their sizes range from slightly smaller than Earth to more than twice its mass. Among them are super-Earths, which are larger than Earth but lighter than ice giants like Neptune. One of the most fascinating discoveries in this category is Proxima Centauri B, a super-Earth orbiting the star Proxima Centauri. Estimated to be about 7 times Earth's mass, this planet lies relatively close to its star, but may still fall just outside the traditional habitable zone. Proxima Centauri B isn't alone. It has a sibling, Proxima Centauri C, located farther out in the system. This planet completes one orbit roughly every 5 Earth years and was confirmed in 2020 using archival data from the Hubble Space Telescope. Even more intriguing, Proxima b may be unusually bright, possibly due to a ring system reflecting its star's light. And the mystery deepens. In 2019, astronomers detected an unexplained variation in Proxima Centauri's radial velocity, hinting at a third planet. If confirmed, it would be called Proxima Centauri d and would be roughly the size of Mercury or Mars. Imagine a night sky filled not only with stars but with alien worlds, each with its own unique climate, composition, and orbit. The cosmos is a vast treasure trove of celestial surprises, and exoplanets are among its most exciting discoveries. With thousands identified and more emerging regularly, it's a thrilling era for astronomers and planetary scientists. Though we don't yet know the full number of exoplanets, it's now clear they may be as common as stars themselves. However, spotting them is no easy feat. Most are hidden in the glare of their host stars, making direct observation incredibly challenging. Yet, with advancement in technology, astronomers have managed to directly image a select few. To do this, a planet must meet specific conditions. It must be massive, orbit far from its star, and be young and hot enough to emit infrared light. Still, most exoplanets are not found through direct imaging. Instead, scientists detect them indirectly, primarily through the radial velocity method, which measures the gravitational wobble a planet causes in its star, or through the transit method, which tracks dips in starlight as planets pass in front of their stars. NASA's Kepler Space Telescope revolutionized the field with the transit technique, yielding vital data on planetary sizes, orbits, and potential surface conditions. Consider these compelling statistics. More than 22% of Sun-like stars are believed to host Earth-sized planets in their habitable zones. The TRAPPIST, one system, for example, contains 7 rocky planets, several which could support liquid water. Like the moons in our solar system, many of these exoplanets are also likely to host natural satellites or exomoons. To date, over 4,000 exoplanets have been confirmed, and they appear to be scattered throughout the Milky Way. Hot Jupiters, due to their size and proximity to their stars, remain the easiest to detect, but many more diverse and exotic worlds remain undiscovered. At the forefront of these explorations is NASA's James Webb Space Telescope, JWST. This powerful observatory is unveiling the secrets of the universe with stunning precision. Recently, JWST made a historic discovery, the first clear detection of carbon dioxide in an exoplanet's atmosphere on a planet orbiting a sun-like star about 700 light-years away. This groundbreaking find offers crucial insight into the planet's chemical makeup and evolution, marking a significant milestone in the search for extraterrestrial life. NASA Administrator Bill Nelson called this discovery an entirely new view of the universe, igniting widespread excitement among scientists. JWST's contributions don't stop there. It has captured breathtaking infrared images of deep space. In one instance, it observed 110 IRS-4, a cosmic object illuminating a cloud of cold, wispy material. The image revealed orange glows from distant stars hidden behind layers of ice and dust. This is part of the Ice Age Initiative, a project investigating how ice forms in space, from microscopic grains to massive comets. Additionally, the telescope has, for the first time, captured the structure of a dusty disk around a nearby red dwarf star in infrared, another leap in our understanding of planetary system formation.